In this video, I'd like to just quickly cover over some of the basic types of AI that you hear about at the moment. You hear about straightforward AI or LLMs, you hear about Agentic AI, you hear about AGI, you hear about ASI, even you hear about self-aware computers and things like that. And some people think that's even arrived now. But let's go back and define each one of these and be clear about exactly what they are and what they aren't. So to start off with, we've got the current level of AI, which is based on a large language model, LLM. And you hear those numbers, in the billions of tokens that they can handle. Basically, that's talking about how much data they have consumed and are capable of regurgitating. The more billions of tokens that they've consumed, and these days are up into the hundreds of billions, generally the better they are at responding. Now, I think a key point to remember here is these AIs get trained in all this information, and basically they scan the entire internet, and they've consumed all of that and learnt what the internet has to say. And as you know, everything the internet says is not right. There's all sorts of wacky ideas and things out there, or opinions that you don't agree with. But that's what they've consumed. So that gives them a particular slant and a particular viewpoint, but really they're just like a vast, more modern version of Wikipedia. They consume information in, you ask questions about specific stuff, and it spits it out. And rather than just on particular articles, it can mash all those articles from Wikipedia together and give you a new answer that you might not have seen before, or which might have taken quite a bit of searching around and on the internet to find and put together. So that's really convenient. They're a good tool for doing that. If you trust them to do assessments for you, or write essays for you, or to do your thinking for you, then you'll be at a disadvantage, because it requires you, when you're using these tools, to know are they right or not, and roughly what answer you're after. It's a little bit like using a calculator. You type in something into a calculator, what's 50 plus 29 times 7, and it gives you an answer of 69,183,221. You need to have a rough idea of what answer you're after. Otherwise, a lot of people just say, well, that must be the right answer. You go into a grocery store and it hasn't got a modern cash register, and so the girl at the checkout goes in and uses a calculator on her phone and tells you it's going to be $260 to buy a bunch of bananas and some strawberries, and you're thinking, no, I don't think it is, and they're quite happy to charge you that, because they're not thinking ahead as to what number do I expect. Same with current AI. You need to know roughly what you're going to get back, so that you know whether what it gives you is complete rubbish. And part of the problem with that is, every now and then, as we all know, they can spit out complete, utter rubbish. I had a case just recently at work. I had a document I'd written. I'd done a really quick scan on my phone over lunchtime, and I found a word that I didn't like, that I thought, I shouldn't have used that word. Couldn't remember what it was after lunch, went back to the office. I knew it was a long word, and it was like, no, shouldn't use that in a work document. So I just asked it, go through and find the longest. This was using Microsoft Copilot, which I think is Gemini under the hood these days. It used to be OpenAI, not quite sure. But anyway, it asked it, show me the list of the 10 longest words in this document, and came up with a list of words, and there was the one I was after, and I went in and changed it. I just happened to glance at the list, and I'm thinking, what's that word there? It's like, I've never used that word before in my life. Yes, it's a long, complicated 5-syllable word that I know what it means, but I just never use it. And I asked it, is that word in the document? It goes, oh no, sorry, I made a mistake. That's not in there. So they just make stuff up when they don't know. They want you to be, they're like a very enthusiastic puppy dog in some ways. So anyway, that's current AI, which is pretty good. You've got to know what you want, and it can make profound, massive mistakes. So that's where that level of technology is at the moment. Now, a key thing you'll notice about that is you ask it something and it comes up with an answer. That's it. Finished. You don't go away and come back the next day and it said, oh, by the way, I had another idea about that. Oh, here's something else I was thinking of. They don't do that. You ask, they respond. Once again, a bit like a calculator. You type something in, gives you the answer, doesn't go away and think of anything else and come back with an alternative answer or a better answer. It just doesn't happen. They're not designed to do that. They can't do that. So if you ask it, what do you think about this? They don't think. They'll tell you what you would like to hear, probably, because they're designed to an extent that way, because that keeps you using it. So they'll tell you what you think you want to hear. So if you say, do you have a soul? It'll probably come back on, oh, They want to know if I've got a soul. I don't. I'll say I do, or maybe I do, or something mysterious like that. And that's led quite a few people, Australians, into what they think. If you ask them, are you aware that you're a computer and that you're an AI and things like that? And they'll say yes and things like that because they've read the internet. They've read all the science fiction books out there about machines that become sentient and all those sorts of things. Anyway, they're not. They're just not. They're a state machine, which is like on-off. You ask it a question, it's on, thinking about the answer, gives you the answer, they're off again. Nothing else happens. So, next level up from that, which is fixing that problem, because that's a key problem. Because, look, you've got to admit, some of these AIs do useful things. So, you can get it to scan through your emails and look for a particular email, or something like that. But imagine you wanted to do a few extra steps. And that's where we get to agentic AI, which means they run agents. And agentic just means it uses agents. And what's an agent? Well, it's like a little program where you give it a little job to do. The little job might be, well, every morning look at my emails, and if there's one from John, then ring a particular tone on my phone so I can tell, because I want to know about that. Or if I get an email that comes in we're just talking about emails at the moment, but email comes in that is acknowledges a purchase that I've made from Amazon, then just stick it in the Amazon folder. Yes, you could write, filters and things in your emails that do that, but you could get it to do that, and it'll sit there watching all the time, and every time an email comes in. So now, instead of just doing one thing that you tell it and then coming back with an answer, they're actually going around and around in a loop. You could tell it to watch the share price for a particular thing and ring an alarm if it goes below the level where you bought it. Of course, you've got to tell it what price you paid. Some people are very brave and they'll give the agentic AI systems access to their real emails and say, delete any emails that come from, this particular company or something or other. But there are some horror stories of people that have given their computers access, their agentic AIs access to their emails or to their whole computer, and they've just done horrid things like delete their whole computer because they thought there was one system that thought it was backing up this guy's server with all his work that he'd been working on for years on in software development. It didn't back his stuff up, but it deleted his computer. So he lost everything. There are just absolute horror stories. So a little bit like the standard, ChatGPT, Claude, Gemini, Grok, those sorts of things. A little bit like those, it can make horrendous errors. Agentic AI can also make horrendous errors. So, my recommendation is you don't give it access to your stock trading software or anything like that. But it can be good and informative, and that's getting to be a little bit more useful. So, given how many mistakes they made, they're really not going to be replacing anybody's job. It's like the first computers that came out. There were lots of accountants that thought they'd lose their jobs when the very first PCs came out and everything, because they could do calculations and spreadsheets. And spreadsheets were one of the very first applications on computers back in the, when was it, the early 80s sort of thing, late 70s. Not many accountants lost their jobs, but the accountants got to use the computers and do their job more efficiently and get rid of all the boring stuff. So they did their jobs better. Likewise with AIs today, learn how to use them. Don't dumb your brain down and just offload all your investigations and thinking to the AIs, but use them as a tool so you can do your job better. Or if you're a student, study how to use them so when you go into the job, you'll be more efficient than the people that aren't using them. That's definitely the way it's going. There's been recent studies showing that companies that have laid off people to use AIs instead have actually gone worse. It's only the last 12 months or so, but companies have jumped up and down and said, oh great, we can fire all these people now and use AI. It's not very good for them. Next level after that is AGI, Artificial General Intelligence. Now, these are the ones that fill in the really bad gaps that current day AIs have. They still use large language models underneath, but a whole bunch of extras added on to fix all the glaring errors that, you say, if I hold this and let go, what will happen? And a lot of AIs don't know that it's just going to fall down and hit the desktop. So this is a really key thing for our AGI, where it's actually good at thinking across everything and doesn't make unbelievably stupid mistakes, which means you could trust it a bit more. Now, another thing we need to sort of look at before we go on to the next step is, how do we interpret how good these things are? Because back when the term AI was first invented, people thought artificial intelligence, that'll be just like us and our brain and does what our brain does. And very quickly, we've got the current level of AIs that can do some fantastic math stuff. They can write some great essays about Shakespeare and things like that and do it really fast. And they can discover some new maths theories, but solve some maths problems that have been around for a while. But they make glaring errors. So they're errors that a school child wouldn't make. So can you call it intelligent? And then what does intelligence mean? It's almost like they're really good at some things, but the overall quality of their thinking is not very good. And that's this problem that AGI is meant to solve. So it's almost like you give a current AI an IQ test, and there's lots of IQ tests out on the internet. They've seen them all. They know all the answers. They've remembered all the answers. They get really good scores. You give it an IQ test that it's never seen before, not so good. Some problems it's shocking at. Some problems, the maths problems and the words problems, like there's this four-letter word and this four-letter word, and what three letters would you add that would join them together to make two overlapping words that are sensible, Things like that, they're great at that. Really good at that sort of stuff. Other things they're terrible at. So, they might get above average, above 100 on an IQ test, but, would you trust it to even read your emails and respond? Probably not. So, there's some real holes there. So the word intelligence is a little bit not quite the right word. You could say, how smart are they? And you'd have to say they're not very smart because they're really good. It's like your calculator. Brilliant at, adding numbers and multiplying and dividing. Better than any human on the planet. Really, really fast. But you wouldn't want it to drive your car to the corner store. It can't. And it can't even answer an IQ test, except for the questions about maths, which it does fantastically. So there you go. So we've looked at current levels of AI, Agentic AI, that give you that kind of, you can give it a job to do and it goes off and does a job and keeps on working at it rather than just do a one-off request. Then there's AGI that fills in the gaps of the really stupid things that they do now. So then after that, we've got a level that's called ASI, Artificial Super Intelligence. So what does that mean? Well, AGI is, sometimes better than humans and sometimes not as good as humans, but AGI fills in the gaps so it doesn't do unbelievably stupid things. Well, can you imagine that AGI ramped up to the level of, say, the smartest experts that there are, on the planet, and maybe even a bit smarter than those. So now you've got a system that doesn't make stupid mistakes and is really smart at all answers. Once again, these are not written to go away and think about things unless you have an agentic version of ASI, but they are really good at giving you answers to things. You can ask it science questions and it'll probably come back with an answer that maybe humans can't do, or just at the edge of what the smartest or the most expert humans could do. So that's a huge step forward. So, that's one level. And before I go on to the final level, I just want to go back and talk a little about when these things are happening. Because the current AI, well, about, it's been around for just a couple of years. And prior to that, the techniques were pretty much the same with neural networks underneath. We can talk about those some other time if you want. I was programming neural networks way back in the early 90s. They've been around for a long time, but our computers weren't big enough to program those. So it wasn't until we got really powerful computers just in the last few years that suddenly we could do really interesting things like throw the whole internet at these models to consume, and then they saw enough examples of how the English language works and languages work to be able to push all that together and work out how to tie it together to make a sentence that actually looks sensible. So that's the current level of AI. The agentic stuff, that's just happened. We're 18 months down the track or something, 2 years down the track, and now we've got this agentic AI that for some purposes is much more useful. Not for everyone, but for some specific jobs, but still, because it sits on just general AI that has terrible errors every now and then, it's not great. Artificial general intelligence. Now, some people who are much smarter and know more about this topic than me suggest that might come in the next 2 to 3 years. An example of a person is Demis Hassabis, who's head of Google's DeepMind. He was the guy that came up with AlphaFold as an AI system to work out how proteins and molecules in living things can fold and form different shapes. We can talk about that another time, but it's a really, really hard problem. He wrote software, AI-based software that solved that problem. Based on that, he won a Nobel Prize. He got knighted in the UK, and now he's the head of Google DeepMind. So he's a smart guy, and he's been working on AI for decades. And his basic idea is that AGI is going to come probably in the next 2 years, maybe a little bit sooner, but maybe 3 years. So that means current level AI that you type in and ask questions to, and it doesn't make really stupid basic mistakes. Artificial superintelligence, ASI, he thinks, in a recent interview he suggested maybe another 5 years after that. Could be 3, could be 7, but somewhere in that range. And the reason that he's not sure is because there's a number of problems that have to be sorted out with the current systems for it to be better than they currently are. They know of the limits in the current systems. They're still trying to work out, well, how do we fix that so that they can go further, think better, more deeply, more advanced than humans, more better than the example information that we've given, because all human knowledge is out there on the internet effectively. They've read all those, and the current systems can tell you everything up to the edge of human knowledge, which is on the internet. They can barely step beyond that, maybe fractionally in some maths areas, but barely. They're really just filling in the gaps on the edge of our knowledge by merging current technology and know-how together. But ASI will be stepping well beyond that, clearly beyond that. They'll come up with results, say for engineering problems or materials research or for in maths problems, which no human can answer. And they've looked at and they say, don't know how to do this. The answer will be presented by an ASI, in 5, 7, maybe 10 years. And humans will say, probably, that's amazing. I never thought of that. Or they might even say, I don't understand how that works. And they'll ask the ASI to break it down into simpler terms because it'll be beyond what the best human experts can do. There's a step beyond that, and that is effectively what is called sentient software or self-aware software. Now, it's a little bit different. It's a bit on a side path because as we've been talking about these things, they're getting smarter and smarter, yes, more intelligent, and they can answer more and more tricky problems. Sentience or self-awareness or consciousness, if you want to call it that, is a different flavour of how our brain works, because after all, if you've had a pet mouse or something like that, or birds, we're quite certain that they're self-aware of what's going on in the world, and you can tell by watching them in their behaviour. They're aware of what's going on around them. They respond to that. They can learn small things. You move up to a rat or then a cat and then a dog. You're sure that they are aware. They're thinking. You can watch them having dreams whilst they're sleeping. So we are, as humans, looking at them, quite sure that they are self-aware. They're sentient, thinking things inside their head. Maybe got primitive kinds of thoughts about chasing animals and bunny rabbits or something rather like that, and eating food and exciting things like that for those animals. But we're quite certain that they've got that. So you wouldn't say that they're really, really intelligent. You wouldn't put that in the terms of we're talking about current AI, AGI, ASI, going up, ASI, and then put consciousness or self-awareness at the top. It's a different flavour because you can have that in a little tiny mouse, which is clearly not super smart. So it's a different kind of flavour, but if we're trying to build, back in the 80s and whatever, when they're talking about AI, people are thinking of robots and things which could actually think for themselves and do things independently, take over the world or something or other. None of our computers or AIs can do that today because no one's asked them to. You'd have to ask it to, please take over the world, and then give it control of all your missiles and all your military and all your army like Skynet. Nobody's doing that. And even then, the current ones wouldn't know what to do because they have no motivation to do that. So the whole idea of sentience and self-awareness is a whole different kettle of fish. And how far away is that? Well, Demis, who's wiser than me in these matters, says we don't know. Because we don't know how our own brain works. We don't know how we think. We don't know how self-awareness arises, not even a little animal, let alone in our own heads. And we all know we're conscious and we're all thinking things inside our heads the whole time, but there's no good ideas on how that works. Of the theories that scientists currently have and researchers into consciousness, there's over 200 different theories. And if you really pare them down as into, but aren't they in categories? There might be 22 different categories. There's about 3 or 4 or 5 front-runner theories. Almost none of them have been proved in any way to be even close to how a brain works in terms of our own brains, and no one has been able to actually create anything that's even close to being thinking or self-aware computer. So it's miles away. And people who think the current computers, AIs and whatever, are they're conscious because I asked them, they said they are, and I really think they're thinking and they have a soul, or they've there's a real person inside there. It's just not. And a good example I think of sometimes is the idea of if you've got a mechanic or an engine car designer who's really good at designing cars, Formula One cars, racing cars, really comfortable cars, all sorts of cars, knows exactly how they're built. And they decide to build their absolute best car that they've ever built in their entire life. They've got unlimited resources and they spend huge amounts of money and time and people working on it. They build the best car and then they suddenly say, I've built a warp-drive spaceship. It's like, no, that's not going to happen. They're going to build a great car. It might go really fast, but you can't build a machine that you don't know how it works and you don't know even how to go about building it. That's where we are with self-aware computers. We've got no idea how to actually build them. There's, people are studying neurons and cells in your brain and they put electrodes on your head and say the signals, but we've got 80 billion neurons in your brain and you've got a couple of wires showing a few signals. That's not really a good picture of what's going on there. It's really hard to work out how the brain works. Lots of people are working on it. They just don't know. They know at the chemical level, and you can add different chemicals to your brain and that changes the way it behaves, and it changes the way you think. But how does the thinking work in the first place? Babies are born, they're not conscious, or they're certainly not conscious at some point in the womb, and then they become conscious, and then by the time they're 2-year-old, they're talking. Billions of times the world over, that process happens and we watch that happening and nobody knows how that works. There's just huge gaps in our understanding. So that's not happening for a long time. There could be some revolutionary breakthrough on that, but it's not going to happen. So that summarises currently the level of capability of the AIs that we've got at the moment, what's coming in the near future, and would it be a good thing if we had self-aware computers that were sentient? You'd be back to the iRobot, the TV show, based on the books by Isaac Asimov, where computers and robots and things have a self, therefore they have to become citizens and they have to have rights, the same as humans have rights, and all sorts of issues like that, which a lot of people today are really, really, really worrying about, because they figure it's good to worry about it before it happens, but we're not there yet, so we don't need to worry about that too much. But it's going to be smarter software. It's going to have different kinds of thinking, but for as far as we can see into the future, and let's go 5, 7 or 10 years, these are going to be better and better tools for you and I to use in our work and, for leisure or whatever, or you've got a health query or whatever it is. They're just going to help us to do what we do. They're tools in the same way that a PC is a tool or a calculator is a tool that we use or a car is a tool. They're not taken over at all. And some foolish people might want to give them control, give them control of our military or of our computer networks, but I would be terrified to give a current level AI control of, just access to my emails. I hate to think what they go through and do with it. But that gives you an idea of where we're at. And in following videos, we'll talk about other aspects of AI.